Here's a beat up, dirty, scratched up Westinghouse model H649T7. This set is from around 1959. It's a 7-tube AM/FM set. I got this radio from the same lot of radios that was at a estate sale. Alright, let's plug it in and see what happens to it. It appears this set's probably dead. So if we got see if we got any vacuum tube, vacuum bulb illumination. I don't see anything. So it seems like we have a dead set. So let's pull the back off of it and see what the problem is. Here's the chassis of the set. Looks like a 7-tube set, as I said before, with a printed circuit board. So couldn't get any kind of bulb illumination. So let's plug this thing in and see what happens. Let's plug its cheater cord in it. See if we get anything, any kind of reaction. Okay, it just appears that we have a dirty power switch. Had to pull it off and on several times to get it to come on, but I've got the dial lights illuminated, and it sounds like we have a filter capacitor on. A little bit of a signal here. Let's see. Wiggle some of these tubes and see if we can get it to come in a little better. We got a dirty tube socket or something. I think these are the FM part of it. Yeah, I'll spray these tube sockets and see if that does anything. Okay, I just touched up some cold solder joints on the 50C5 audio output tube, and that seemed to help things where I can actually get a little more audio, but as you can hear, it don't really sound too good. Got a lot of audio distortion, so I think it might be about time to make some voltage checks. Alright, and doing some voltage checks, I see that the plate of the 50C5, we got about 105 volts there. That seems about normal. And the grid, it's a little bit positive, that should be negative. And the plate of the second audio tube, which is a 12AV6, there's hardly any voltage there. So this, something here seems not right. we're getting a nice negative voltage on the input of the 12AB6. We should be getting, I would say, 40 to 60 volts here, and we're not. So I'm gonna get out the signal tracer and see. I think there's some sort of issue with this second audio tube getting audio to the first audio tube. Alright, we got our signal tracer fired up here, and so what I'm going to do is check the audio here. Well, not really getting anything there, but let's see. Well, it's basically the same distorted audio we're getting out of the speaker. So let's go to the output of the first audio tube, 12AB6. It's the same distorted audio there. Now let's go to the input.
From the Word of God.
So it's actually louder going in the tube than coming out. So that's telling me that there's something going on. It's going in and not coming out. Now I've already tried to replace the tube to see if that may be not conducting or something like that, and I've checked it too, and it checks fine. And I've swapped the tube out, and there's no improvement. It's the same thing. So I'm suspecting this couplet is bad. So what I want to do is pull that couplet and get the schematic out and compare. I'm going to take some readings and check. I'm going to check the resistances and capacitances inside of that I call it a couplet, but a lot of people call it a couplet. We'll call it a couplet for being correct sake, I guess. But anyway, I'm going to pull this couplet out, and just to give you a little brief explanation about what a couplet is. A couplet is a predecessor to the modern IC chip. It contains, inside of this application, it contains several resistors and capacitors all in one sort of chip or package. It was the 1950s and 1960s beginnings of combining components into an integrated circuit, basically. And in a lot of these, you know, line-driven sets like this one from the 1950s and 60s, they would put them in the audio circuit of these radios. They're fairly common in a lot of these radios. This radio being from 1958, it was fairly common by then. But anyway, I'm going to go ahead and pull that couplet and we'll see what's going on with it. Okay, so here's our couplet, and like I said, this is basically the first, you know, beginnings of IC chips. So the notch indicates, it starts from the notch 1 through 7, and we have our couplet here, and this actually shows wells inside the couplet. We have a 0.005 microfarad cap from pin 1 to pin 2, and then connected to that from pin 2 to pin 3 we have a 4.7 meg resistor, and then connected to that we have a 220 capacitor that goes down to a 470 k ohm resistor. up here we have a line going from between the capacitor and resistor over to pin, what is that, 6. It makes a connection here. Over from that we have, which this incorporates pin 4. Then we have a 470 microfarad, or 470 k ohm resistor going from pin 3 over to pin 5, and that makes a connection. And then you have your 0.005 microfarad cap that goes down and makes pin 6, and also has that connection from pin 4. Then going over, we have a 0.005 microfarad cap that goes down to pin 7. Oh, excuse me, a 0.003, and that makes pin 7. Now, all this can be rebuilt and made with just standard replacement through-hole components, and that's what we can recreate this. It won't look very good, but it will work. So anyway, let's get back to the component at hand. So as I said before, between pin 1 and 2 we should have a 0.005 microfarad cap. So let's test and see if that's what we get. Alright, I had to cut the camera off to connect the probes. We're getting 0.006 to 0.007. That's close enough. So that part is good. Alright, so from pin 3, if you can see that, to, which is one side of the 220. Try not to hold my finger in the way. And then on pin 4 we have a connection over to pin 6. So connecting a capacitance meter between pin 6 and pin 3 should give us around 220 picofarads. Connected to pin 3 to pin 6, we're getting 209 picofarads. So pretty close. Not dead on. It's probably not going to be dead on. It's a, being a almost 60-year-old component, 1958 to 2017, 59 years old. Anyway, so that, yep, we're getting about what we need to there. Alright, so from pin 5 to pin 6 we have a 0.005 microfarad cap. So we're connected from pin 5 to pin 6, and we have 0.007. Pretty close. Alright, so from pin 7 to pin 5 we have a 0.003. That's my chicken scratch up there because I couldn't read that. And we have 0.002. So all the capacitors in here seem to be fine. Well, they're basically disc capacitors in a nutshell, basically. So they're most likely going to be good. Let's check the resistors and see if they've opened up or changed value or what. Alright, so here on pin 4 we have a 470k resistor. One side of the resistor is 4, it is pin 4. The other side, there's a connection that goes over to pin 6. Now we're not making a connection with any of these capacitors. This makes no connection to here. So we're not making a connection to this capacitor. We're only making a connection between here and over to here. This capacitor, is not connected to anything, so in the circuit. So going from pin 4 to pin 6 should generate 470K. Well, not here, we have an open. So just to show you, 1, 2, 3, 4, 5, and 6. So that's 2 connections there, and we have an open. Let's see what else we find. On pin 2 and 3, here at the top, 2 and 3, we have a 4.7 meg ohm resistor. So theoretically we should get that if we measure from here to here across this resistor. It does have a capacitor in line, but again, we're not making a connection to both sides of that capacitor. We have another open. So we already know this thing's bad. There's one other connection I want to show you, and that's the 470K over from pin 3 to pin 5. Alright, pin 3 to pin 5. Remember, it was a 470K ohm resistor. We're measuring 5.35 meg. Yeah, that's right. So, yep, I think all the resistors in this component are pretty bad. So we're gonna have to rebuild this couplet here. Okay, so again, just to recap, we'll need a 0.005 capacitor. Make that 2. We'll need a 0.003. We'll need 2 470K ohm resistors. We'll need a 220 picofarad capacitor and a 4.7 meg ohm resistor. So let's get to work on this, and I'll show you what it looks like. Now again, I know this is not pretty, and you know, it is what it is, but it will work. Pin 1, here's our 0.005, or I've got a 0047 capacitor, disc capacitor, and we have our 4.7 meg ohm resistor going over to pin 2, and then to make pin 3 we have the other side of the 4.7 connected to our 470 along with our 220 picofarad capacitor, and that goes over to pin 4, and then there's our connection over to pin 6, and also our 0.003 and 0.005 capacitors connected to the 470 and down to make our 0.003, which is our tone capacitor, and our 0.005 there, and like I said, our connection over. So even though it's ugly, let's put it in the radio and see if it works. Alright, so here's our rebuilt, lovely looking couplet, or couplet. I keep saying that, but anyway, couplet here, right next to our tube socket. So let's put our tube back in and see if she works. Oh yeah. Well, that sounds a lot better.
Are first, and it is as though when the last
Well, that sure cleared the sound up. I'd gotten to where I couldn't even hardly hear a sound on this thing. Probably should hook up an outside antenna. I don't have one hooked up. I'm sure this set has other problems. Probably needs to be aligned and everything else. Seems to be a little hotter on the top end of the band. That's not uncommon. It seems like a lot of radios I get are like that. Let's try FM. Yeah, it sounds about dead. Well, it's coming through, but it's not loud either. Well, at least we got the audio problem solved. Yeah, we'll have to work on the FM and see what's going on with it too. But at least we have our AM back.
So much other information.
Got a fair amount of sound on it. That interference is the light.
On the web, on social media, to take
all right.
And then I go.
And just a little personal thought about this couplet is you know, I rarely see these things go bad, but I think in this case it might have went bad because of this. It's right next to the hottest, you know, tube in the set. They had this sandwich right here between both of the first audio tube and the you know, main audio output tube. And a 50C5 has a 50 volt, you know, filament, and it gets really hot. It's the hottest tube in this set because this one doesn't have a rectifier tube. It's got a selenium rectifier, which seemed to test okay, but I'm on the fence about replacing that or not. I don't know if I'll want to get into that or not. It's kind of borderline, but we've already put a lot of work into this set already, and it's really not worth that much. So, you know, but just for the sake of wanting to get it running, you know, sometimes we do a little more than we should sometimes. All right, well, we got it working on AM pretty good, so we'll hold off for now, and this video's gotten pretty long, so we'll finish it up with part 2 later and get the FM working.